Okay. Sorry about that. Just started the recording. Just missed a small part. But solving for an empirical or molecular formula, we first convert to grams, then to moles. And in the rare instance that they give you each element in terms of moles, you don't have to revert them back to grams just to convert them back to moles, right? If you're given each element in terms of number of moles, you just move on from there. Okay, so once you have each atom in terms of grams, you convert to moles using the molar masses of each. And then once you have moles of each compound, you are going to divide all of them by the least number of moles. Okay, that is always your next step after getting them all in terms of moles. Okay, and this will typically give you whole number ratios of the elements in the empirical formula. Okay. Okay, and again, when we go through examples, I think my examples show these pretty well. So you're going to divide them by the least number of moles, and then you will multiply all the quotients that you get from this division by a coefficient if needed in order to make them whole number ratios. If they're already all whole numbers, you do not need to multiply them by a coefficient. And again, my examples will show this. Okay? And then your last step, it depends. If they ask you for an empirical formula, you are already done. But if they ask you for your molecular formula, you're going to take the molar mass of the entire compound and divide that by the molar mass of your empirical formula, and then you're going to take that quotient and multiply all the subscripts in your empirical formula by it. Okay, and I know that in terms of words can be pretty confusing, but I think once we go through these two examples, it will show all these steps very clearly and well. Are there any questions on these steps before we get into the two example problems? Okay. So again, if you're just joining kind of recently, please sign in using your NetID. And if you haven't yet, today's activity was just to write a study strategy that either really helped you study for this exam and prepare for it, or something maybe you wish you did better, a resource that wasn't as helpful as you maybe thought it would be. And I'm just trying to compile these to help students see what's working for other people, maybe give them a new type of strategy to approach the next exam with. Okay. So in terms of our formulas, this is the... Sorry, I think somebody just asked why we sign in. You do not get extra credit, yet if you need a little bump at the end of the semester and you talk to your professor and you show them effort, for example, coming to SI, they probably are a little bit more likely. A little bit, maybe, but no, it's not extra credit. The reason why is it goes to my boss, who's in charge of all the SIs, and basically the reason is more for his bosses. If they say, hey, a lot of kids are coming to SI, you can see that these kids are on average doing a little bit better in their classes. Really, it's funding so that we can hopefully expand into more classes and more upper level classes for more. We have a lot of SIs for freshman level classes, but not a lot for sophomores and juniors. A lot of people do find it helpful, and so the hope is that we can expand into more classes in the future. But that's really the only main reason for it. Okay, so example 1. A compound contains carbon, hydrogen, and sulfur. These elements are found to have a mass percent equal to about 53%, 11%, and 35% respectively. What is the empirical formula of this compound? Okay, so first things I would say to note is we have 3 elements, so carbon, hydrogen, and sulfur. There are no other elements. Okay, we're given mass percents of each of these elements, and they are having us solve for the empirical formula. Just things to point out before starting it. Okay, so if you look at our list of steps to do, the first step was to convert to grams, right? And so if I say this unknown compound with carbon, hydrogen, and sulfur, I'm going to assume we have 100 grams of this compound, okay? If I say that and make that assumption, I can drop the percentage signs of their mass percents and just write grams. So instead of 53.27% carbon by mass, I'm just going to say I have 53.27 grams of carbon, right, I have 11.18 grams of hydrogen. I have 35.55 grams of sulfur. Okay, so that's why we make a 100 gram assumption. Okay, your next step is always to convert from grams to moles. So we do this for each atom respectively. And so for carbon, we have again about 53 grams, and its molar mass is 12.01 grams per mole. So doing this math, I find that we have 4.435 moles of carbon. When I do the math for hydrogen, I find that we have 11.091 moles of hydrogen. And when I do the math for sulfur, we have 1.109 moles of sulfur. Okay? Once you have that, your next step is to identify which atom has the least number of moles. Okay, so carbon has a little over 4 moles, hydrogen has a little bit over 11 moles, and sulfur only has about 1 mole of compound. And so we are going to divide all of these by the moles of sulfur we have. Okay, so we're going to divide them all by 1.109 moles. Okay, and what this is going to give us is our subscripts in our empirical formula. So when we do this division, we will find that carbon comes out to 4.00, hydrogen comes out to 10.00, and sulfur, we divided it by itself, and so it should always come out when it's the lowest number to 1. And so this is telling us that in our empirical formula, those numbers that we do, that we get at the very end, are our ratios. So right, for carbon, we have 4 carbons, 10 hydrogens, and a single sulfur, which means our empirical formula is C4H10S. Okay? Any questions on this? What do we do when we don't get easy numbers? Good question. I will hold off on your question until the next example, because I chose the next example because you won't. One thing I will say is you will not get numbers that are too funky, okay? Right here, again, if you can see my cursor, right, before you divide by 1.109 moles, those numbers can sometimes look funky. But when you divide them all by the least number of moles, in this case 1.1 or so, they will pretty much always come out to a relatively even number. Whether it's, 4 flat, sometimes you'll get it where it ends in 0.5 or 0.25, but we'll explore that in the next problem. Okay, so you guys can just kind of read it. If there are any more questions regarding the last one, I'm happy to answer before we start this one. Okay. So this one's extremely similar to the last one. We have an unknown compound. It has carbon, hydrogen, and this time oxygen instead of sulfur. What is if the molar mass of the unknown compound is 222 grams per mole, what is the molecular formula of the unknown compound? Okay, so here they're not asking for the empirical formula, they're asking you for the molecular formula. And the only other real difference here is that instead of mass percent, they give you grams of each one of your elements. Okay, so same process here, right? We're going to take grams of each, so we have about 30 grams of carbon, about 5 grams of hydrogen, and 26.78 grams of oxygen. We're going to use their molar masses to convert from grams to moles, right? That's our first step, or really kind of our second step, but we already had it in terms of grams, right? So our next step would be grams to moles. What we find is we have 2.51 moles of carbon, 5.02 moles of hydrogen, and 1.67 moles of oxygen. And so our next step is, again, always to divide by the least number of moles, which in this case is 1.67 moles of oxygen. And so when we do this math, we find that our whole number ratios is 1.5 for carbon, 3 for hydrogen, or 1 for oxygen. Okay? And so this gives us a general formula of C1.5H3O1. Okay? But when we write formulas, in like our empirical formula, for example, we cannot have decimal places. Okay? And so this was, I believe, the third or fourth, I think it was the fourth step I listed on the slide with many words that kind of described the steps. One of your last steps is to multiply all these subscripts by a whole number by a number that gets them to a whole number ratio. So if you see, like in this case, carbon is 1.5, you can multiply all the subscripts by 2 to get them to a whole number ratio. And so that's what you do. You'd multiply the whole equation by 2, the whole formula by 2, and your real empirical formula is C3H6O2. Okay? Before I go through to the last step, the last thing I kind of want to say in terms of decimal places here, I kind of said they won't give you weird numbers. Okay, so whenever you do this math, and again, here we got 1.5, your decimal places will pretty much be 0.5, 0.33, or 0.25. Okay, and so from those numbers, you can pretty clearly see if it's 0.5, you should multiply it by 2. If it's 0.33, you should multiply it by 3. If it's 0.25, you should multiply it by 4. And again, that will just make them into a whole number ratio. So do you always just multiply by the least whole number? I'm not quite, Ariana, sure your question. If it's regarding dividing them all by the smallest number of moles, yes, that's really to get the whole number ratios. Do we use sig figs for these? Honestly, I'm going to have to go back to the question. Yes, I would use sig figs for all of these problems. But again, typically at the end, they'll just ask you for a formula, in which case your sig figs don't matter, right? To write the empirical formula, your sig figs were relatively irrelevant, so I guess it depends on what they're asking for. If it is just the formula, sig figs don't really matter. Okay, I'm just going to quickly talk through the rest of the problem, and then I'll answer any further questions. So in this problem, we were not asked for the empirical formula, which again, the empirical formula is C3H6O2. We were asked for what's the molecular formula. And whenever they ask for the molecular formula, you're still going to first find the empirical formula, but then you're going to have to also solve for the molar mass of the empirical formula. Okay, so C3H6O2, when you find the molar mass, will be equal to 74.078. And I saw that question, but I'll get back to it in a minute. I just can't pull it up right now. Okay, so the molar mass based on our empirical formula would be 74 grams per mole. But what we are told in the prompt, and this will be in the prompt, is that our total molar mass of this actual compound is equal to 222. Okay? And so whenever you're solving for your molecular formula, you should take your total molar mass, 222, and divide it by the molar mass of your empirical formula. So in this case, it would have been 74. When you do this division, you'll get a whole number ratio. Okay, you should always get a whole number ratio on just this calculation here. Okay, what you find is this quotient is equal to 3. And so what this is telling you is in order to go from your empirical formula to your molecular formula, you have to multiply every subscript in your equation by that whole number, which in this case is 3. Okay, and so our molecular formula will be C9H18O6. Okay, now I'll pull up questions. Just couldn't really talk through it. And so, somebody said, Matthew, correct in answering that. So the reason why C1.5H3O1 is not our empirical formula is your chemical formulas cannot have decimal places by any means, and so you just have to multiply by a number that will get them all to the smallest whole number ratio, right? So 1.5 times 2 would get it to 3, 3 times 2 is 6, and 1 times 2 is 2. The next question was, where did 222.23 come from? That came from the problem. Okay, and so I gave that to you, and I'll go back. Oh, sorry. That was weird. I went the wrong direction. Sorry there. So as you can see right here, the molar mass of the unknown compound is 222.23. And so whenever they want you to solve for the molecular formula, they have to give you the molar mass of the entire compound. Now, if I, in this problem, instead of 222 grams per mole, told you that the molar mass of the compound was 74 grams per mole, well, you'd solve for it exactly the same. You'd get to the empirical formula. You'd find that the molar mass of the empirical formula is 74 as well. And when you do this calculation, you'd get 1 as your quotient. And what you'd find is that your empirical molecular formula would actually be the same, okay? If in the problem it said your molar mass was 74. But again, it said 200. Okay? Any other questions?
For the total molar mass, was it always going to equal the whole number?
Sorry, can you repeat that?
For the total molar mass, when we took the mass of the original compound divided by the empirical formula, is it always going to equal a nice whole number, or can it sometimes be a weird number?
Yeah, so good question. So when you're doing this last step to convert from your empirical to your molecular formula, it should always be a whole number. And the reason why is your empirical formula should have all whole number ratios. And so if you're multiplying it by a non-whole number, your ratios will then become decimal points and stuff. And so it should always just be a nice, easy, typically you'll multiply it by 2, 3, maybe 4. But yeah, it should always be a whole number ratio.
Okay, thank you.
Yep. I get. So somebody asked, they get that you multiply 1.5 by 2. How do you know what to multiply it by when you have crazy decimals? So again, they won't just give you outlandish crazy decimals. When you get it to the last point, so again, we got carbon down to 1.5, your decimal portion will be something like 1.5, 1.33, 1.25. And so typically you'll be able to undo that decimal by multiplying it by 2, 3, or 4. You won't have to multiply it by like 13 or anything weird. It should be pretty clear what you have to multiply it by. Okay? I'd say the highest number you'd have to multiply it by to get rid of the decimal is 5. Okay, so that'd be like 1.2. 1.25, you would multiply it by 4, 1.333, 3, so on and so forth. Okay. Any remaining questions before I think it's just the challenge problems remaining? Okay. So I will give you guys a minute to look at this. I'm just going to make small little comments. So again, these multiple choice questions, if you think they're easy or not, again, these are basically me rewriting somewhat my exam. And so for the first one, for example, they asked a question just like that on my multiple choice portion of the exam. And I also realized I forgot to change this to multiple choice, so I apologize. I meant to make it A, B, C. And so just kind of pretend. So for the first one, A would have been C3, H9, O6. I do apologize. I overlooked that completely. But yeah, so these are questions basically right from my exam. I would star the second one on this page. The second one, yes, we can go over other questions after. Sorry, I lost my train of thought. So the second one, I would definitely star 100% try that one before next SI. That was probably seen as one of the most challenging multiple choice questions from chapters 1 through 3. I think it's a really good problem. They've, I think, had one like it every single year because it's such a good problem. And it really tests to see what students know. It is tough, so if you don't get it, it's okay. We'll go through it in depth next time. It is a pretty confusing problem. Even the way I wrote the problem, the wording of it, is pretty much identical to how it was on the exam. So I left everything to, again, challenge you guys. Definitely try that one. I mean, I definitely think all of them. Here are a couple. Again, these were supposed to be more multiple choice questions. Yeah, number 3 is a pretty good one. Number 4 is a really good one as well. So definitely try number 4 is another one I would suggest before Wednesday so that you can come with questions to clarify. Okay, and I can go back to any of these. I'm just going to go, I think, to the last slide. Yeah. And here are 4 open-ended problems. So again, your next exam is chapters 1 through 3. It is in a little bit under 2 weeks, and it is multiple choice. Okay, so these multiple choice problems I've been giving you since the first week of SI are really good to practice for those. But again, take these long answer and ask yourself, okay, how could they convert this to a multiple choice question? And also keep doing these long answer ones as well, because chapter 3 long answer will come up in a few weeks. I think it is 4 weeks from now. But chapter 3 long answer is pretty tough. And so I will try to keep preparing you guys for that. It is in a little bit, but these are really good ones to do. I love the 3rd question on this page and the 4th question. They both have a history of making it onto the exams, especially number 3, and really good problems. So I'd highly suggest you guys try those again before I go over them next time, just so that you do have the chance to kind of overcome any spots that you're having difficulty. Doing it on your own is always going to be a little bit better than me walking you through it, but me walking you through it is also better than not doing them. So definitely give them a shot. And yeah, we'll go over those next time. Are there any questions on what we went over tonight? And if not, that's all I have. Somebody is asking a question on a worksheet that we can try to do. I can try to explain, but I'm going to end the recording now. Again, anybody that wants to stay, please do.